Hello friends, today we are going to look at three-dimensional vectors. Now what we've been doing so far, we have been working with two-dimensional vectors. These vectors have the x component and the y component. Now when we come to three-dimensional vectors, we introduce a third dimension. So we have the x component, the y component, and the z component. So let's look at this diagram. We have our x-axis, our y-axis, and then our z-axis, which is also perpendicular to both the x and y-axis, but z is in the third dimension. That is something like a solid figure. Now, if for our x-axis, our x-coordinate is ax 0, 0. The y-coordinate is b 0, y 0. And the z-coordinate is c 0, 0, z. Let me write it, 0, 0, z. Now, that will give us a point somewhere in the xyz plane, m, x, y, z. Now, a 3D vector, this vector m, can be written as a position vector x, y, z. It corresponds to x on the x-axis, to y on the y-axis, and then to z on the z-axis. It can also be written as xi plus yj plus zk. Now, three-dimensional vectors behave just like two-dimensional vectors in terms of addition and subtraction, multiplication by a scalar, finding the unit vector of a three-dimensional vector. They all behave the same way. The only difference is that you have a z component that you have to take care of. So we can consider addition of three-dimensional vectors. So that if we have a vector, let's say P, let's have the coordinates as x1, y1, z1, or xi plus yj plus zk. And we have a vector Q, x2, y2, z2, or Cartesian form, x2, so sorry, this will be x1, y1, z1, and this will be x2i plus y2j plus z2k. So that P plus Q is going to be x1 plus x2, y1 plus y2, z1 plus z2. So we add the corresponding components, or we can write it as x1 plus x2i plus y1 plus y2j plus z1 plus z2k. And the same applies for subtraction. So I can just put plus or minus over here. All right? So I want you to try a few examples. If the vector P is minus I plus 2j minus 7k, and the vector Q is 3I minus 4j minus k, let's find the following. A, P plus Q, and then B, P minus Q. You'll find the solution in the next video.